Thanks everyone for joining. I'm Kate Kendall. I'm from Atkins. We're part of the ST Leveling Group, a wider engineering consultancy. I'm just here to give you a bit of an insight, really, into careers in engineering geology. So today, just going to cover a bit about exactly what engineering geology is, what do we do as engineering geologists and geotechnical engineers, what sort of projects do we work on, tell you a little bit about my experience over the last 6-7 years in industry, and then look at how you could, if you wanted to, become an engineer, the opportunities that there are at Atkins, and then, as Louise said, we'll have a little bit of a Q&A session at the end if you want to. So, let's see if I can get this to work. There we go. So all about careers. So what exactly is engineering geology and geotechnical engineering? I know when I was sort of your age at King Eds, I never really knew about this sort of industry and what sort of things we do. But why is it important? So there's a few sort of snips here from various news articles and also the famous Leaning Tower of Pisa. And these are all things that talk about and show to us why it's important. We've got to understand the ground conditions, basically. This is what we do as engineering geologists and geotechnical engineers. You've got the example that the Leaning Tower of Pisa that was built many years ago is slowly subsiding, and that's because of soft ground. That wasn't known at the time and it wouldn't have been checked. We've got a collapsed bridge because it was built with no ground investigation works. They didn't know what the underlying geology was and the ground conditions were. More recently, and you might have seen this in the news, there was a landslip in Hook, which obviously caused major rail disruption. And at that point, you can sort of see on that picture there that half the rails collapsed, and that was due to a major landslip. And again, we've got sinkholes due to mining. All these are very important. More sort of close to home, some of you may have went over the Crooked House down the road in Dudley. That's undergone major subsidence because of mining in the area. And again, we've also got another rail-related incident here where you can hope to see there's a container put on the top of a railway cutting, and that increased load caused it to slip and fall, and luckily there were no trains going down at the time. But these are all incidents that have happened and may still continue to happen, and it's why it's so important to understand the ground conditions of anything that is being built, is going to be built, and areas that we're working in. Now, what exactly do we do? There's a whole variety. This sort of covers a bit of the life cycle of a project, and we may be involved with all of the life cycle or just small snippets. So at the start of any project, the start of any work that we do, we undertake a desks to do. The eagle-eyed amongst you might notice that this is actually Stourbridge. It's a geological map of Stourbridge. We've got the various bits of geology. Now, this is part of the desk study that we do. We look at the underlying geology. We look at any ground investigation works that have been done to date, and we pull together a bit of a story, a bit of an understanding of what's there to begin with, sat behind a computer, basically using all available online information. From that, we will then do what's called a ground investigation. This is when we get right out on site, literally dig holes in the ground, drill, find out the material that's there. There's only so much you can learn and understand about the site while you're just sat behind a computer. You need to be able to get that information from the ground, because we need to know exactly what we're proposing to build on. From that, there's data management involved, so we'll get all of those results back and be able to compile all the data. So whether that's the descriptions of the soils and the rocks that we're bringing back, and then also the lab data, because we will then be doing lab testing on all of that. So as you can see, you start to piece together now the bit of the life cycle and how we work. So we then take all of that data and get lab results from it. So this will give us help us understand the material properties, whether it's the strength of the material, whether it can compress, things like that, and whether it's how fine or coarse it is. Hopefully all these are sort of words that you'll be picking up on that you might have learned already in your studies. From that, we then get to the fun bit, building the geological ground model, understanding what is going on there. So when I first started, I was doing a lot of this sort of pen and paper. I still do it now. I like to sketch it out to begin with, but we do a lot digitally now, using CAD, computer automated drawings. And so we'll pull together the ground model of that site. Now, our sites can vary from being a very small site for a new school. That's one thing I'm working on at the moment. Equally, we could be talking about a long linear scheme for a new railway line. So ground models will take lots of different forms depending on the size of the site and sort of the nature of the workings. This is an example from a very small snippet from a railway line that we've been involved with over the last few years. From that, this is when it then starts to move into the bit more of the design stage. It's when the sort of geotechnical engineers get a bit more involved. The early stages, sort of the ground investigation and ground modelling, is very much the bread and butter of the engineering geology. And then we start to feed into a bit more of the geotechnical engineering side of things. So we'll do a lot of design for foundations. The top left of the screen there is showing looking at slope stability, and if we're loading the top of a slope, whether it's going to fail. Also got design of foundations for bridges using what are called piles, and again looking at any potential failure there. The aim of the design is to prevent that. So we then take that design and produce design drawings, which will then get taken by whoever the contractor is as part of the construction phase, and make sure that that is built correctly. That will be integrated with a lot of the other disciplines, so it'll be one sort of drawing covering everything. And from that, we do also get involved in construction. It's brilliant to be able to see the life cycle of a project through. So this is an example of the construction of a bridge as part of a new railway project. And so we'll be on site supervising the works, ensuring that the design that we've been involved with is built correctly. A great opportunity to get out and about and see things actually being built. As I've alluded to, we're talking about the life cycle of a project. So it doesn't stop when something's been built. We don't just hand it over. We're also involved in asset management. So that is ensuring that the asset, whatever's been built, whether it's a new road or a new railway line or buildings, are maintained and there's no problems. We're heavily involved with Highways England, looking at those at their sort of assets and monitoring them in case there's any signs of failure or any future geotechnical problems which may arise and do arise. You'll see crackings in roads. That's all part of the asset life cycle. So we also get involved with that. So there's a lot of things as engineering and geologists and geotechnical engineers that we get involved with, and we all get involved with various bits depending on how we specialise. I've sort of alluded to a little bit about the projects we work on during that sort of introduction, but we get involved in all sorts. As I say, we get involved in highways, whether that's a new highway, maintaining an existing highway, or looking at future projects. Again, the railway, whether this is again building a new railway, there's a lot of improvements going on at the moment to existing infrastructure, whether that's sort of remodeling to improve for journey management time so they can get more trains in and out, or whether it's building a completely new railway line or reopening an existing one. There's a lot of railway lines that were closed in the 60s that are looking to be reopened. We're heavily involved with that work as well. Residential, I'm also going to link general building infrastructure into that. So we've got sort of new housing developments, but also new schools, new hospitals, things like that. Anything that needs foundations, we need to understand the ground conditions for. Energy, so whether that's offshore and onshore wind farms, things like that. And then water, so maintaining water courses. Natural water courses are going to cause some sort of erosion. They link to infrastructure, and so maintaining and managing those in case there's any intervention needed. Also looking at slope stability, and linked to that, we also have rock engineering. We are rapidly increasing and growing our rock engineering capacity, which is something great to get involved with as a geologist. Also involved with nuclear. You will have seen in the news we've got various nuclear schemes ongoing in the UK. We're heavily involved with those, sort of the Hinkley Point C and also the new Sizewell C as well. But we may also have sites with a combination. So you can see here we've got highways. the Eagle Eye Launch, you might notice that there's rock netting there as well, and then we've got the railway over to the other side as well. So some sites provides that problem that you've got a whole variety of things going on, and you need to consider different aspects, different requirements by different overarching bodies. So plenty to do, and pretty much any industry you can think of we are involved in some way or another. So that's just a little bit about engineering geology, about what we do. But just I wanted to tell you a little bit about me as well, about my experiences. So as Louise mentioned, I was a student at King Edward's. I did my A-levels there 2009 to 2011. I did geography, biology and music, so a nice varied options there. When I was there, I didn't really know what I was going to do. Really enjoyed geology, so that's what I then went on to do at the University of Birmingham. After taking a year out, I started at Birmingham on the 4-year undergraduate masters degree course. Fantastic, plenty of field trips over to Tenerife, Spain, Wales, Scotland. Brilliant experience. During my time as an undergraduate, I undertook a summer placement at Atkins. So that was between my 3rd and 4th year, which gave me a brilliant insight into engineering and into the industry. I hadn't really heard about it before. It was actually coming to this sort of presentation that I learned a bit about what you could do with geology. Then when this was when I was at uni, so you're hopefully starting to get a little bit of an insight into potential options now. I didn't know about that at that point, but had a brilliant 8 weeks with Atkins, and off the back of that I joined Atkins as a graduate engineering geologist in June 2016, once I'd graduated from my undergraduate degree. So that really opened doors for me by doing that placement. I did also and have recently finished a master's in geotechnical engineering, so I'm sort of the hybrid, bit of an engineering geologist, bit of a geotechnical engineer. So that I did that part-time, and that's sort of where I am now. I finished that last year, so it was a long slog, but got there doing that part-time while working. I've been involved in a whole variety of projects and lines of work while I've been at Atkins, and while I've been in industry. I've only worked at Atkins. I've been there nearly 7 years, but I picked up a key few ones just to talk to you about today. So I was involved with ground investigation for a new railway line, East West Rail, which was actually reopening a former railway line between Bicester and Milton Keynes. So I spent 18 months out supervising the ground investigation works. We had about 400-500 locations, a mixture of trial pits, which are just literally dig a hole in the ground, and drilling rigs coring up to 30-40 metres deep for new railway infrastructure, new bridges, anything and everything really, to inform the design. So see some photos there. It wasn't all sunshine, although a lot of those photos do seem that way, but again, a great experience to get out and about with quite a high profile project. Off the back of that, I was then spent 2.5 years, nearly 3, I only came back last year, on site supervising the construction. It was great to be able to get from doing the ground investigation, the design, through to the construction phase. So I spent 3 years, 2.5 years supervising that, ensuring that the design was being built as it should be, that it was being met. I learned an awful lot doing that, opened my eyes to other aspects, sort of drainage construction as well, and the construction of large scale structures, bridges, and things like that. So yeah, spent 3 years out on site doing that. Brilliant opportunity, and there are many opportunities like that within engineering and at Atkins as well. We've got people out on site with HS2 and also nuclear involvement in the nuclear sites as well. More recently, and something that's very geology related and is assisting me towards my sort of chartership goals, is undertaking mining risk assessments. Now, the Midlands in particular is heavily mines. You know, it's what we're known as the backcountry. This particular example on the screen is from a proposal for a new school in the Midlands. We've got a nice geological map on the left, which shows the site boundary in the schools with some associated cross sections. So you might be, doing them now as geology students, but we're still doing them in the office. As you can see, these ones are a bit more digital. I do still like to hand draw them sometimes just to get that better idea of what's going on. But at this point, we have to start to then consider the interaction of coal seams, whether they've been worked or not, whether there are mine shafts, are they going to impact buildings? So you need to have that understanding of the ground and that understanding of geology and how the mining works. The bottom right hand of the screen is showing the mine shaft interaction. They've tried to put the building, the architects, to avoid the mine shafts, but they are very, very close to that area of influence. So we're currently having that discussion with them at the moment as to whether they can adjust the configuration. There's also the building goes right across a fault, which is not ideal. So there's a lot of work to be done on this site to try and see if it is usable, if I'm being completely honest. So that's quite a small scale project and a small scale mining risk assessment, but we also do much larger scale. This is an example for a reopening of a railway line in Wales. Trying to pull together a whole host of information. This is nearly 10 kilometres long. It is only the one end that's been heavily mined, but we're looking at the stratigraphic column on the side from the BGS memoirs. We're also being given mining plans from the late 1800s, which are interesting to try and understand. But as geologists and as engineers, that's what we have to do. Try and figure out the depths of the mines and how they're going to impact the infrastructure on the top when we're looking at the loading and the ground conditions and the dissipation through that, and understand the materials. So there's a lot that you have to consider, and that's what you learn, and that's bringing in everything that I've learned from A level all the way through to my degree to now. And you're still learning on the job. Don't worry, when you start out in industry, you very much at the beginning, and no one expects you to know everything. I've got an apprentice and a graduate working with me on this at the moment, and we're definitely working together on it to improve their knowledge and their skill base with regards to the understanding of the geology, but then also the other aspects of the job, sort of report writing, presentations, and presenting in meetings and things. So there's a whole host of things going on. But you may put you off, or you may be wondering how you might go about becoming an engineering geologist and a geotechnical engineer. There are various routes. Assuming you're sort of all year 12 or 13 at the moment, so either have already thought about going to university or are just starting out on your A levels. But there are various pathways, and they'll be suited to different individuals. Some of you might be academically inclined, some of you might want to just get straight out there in the world of work. So there are engineering apprenticeships. You can also go on to do an undergraduate bachelor's degree in either geology or civil engineering, and then there's also undergraduate master's degrees, which is what I did. So they generally be 4 years, again, geology or civil engineering. And then often we do within the industry, if you've just got an undergraduate degree, an undergraduate bachelor's, or a non-specific undergraduate master's. So for example, my geology degree wasn't specialised. We then would probably want you to go on to do a postgraduate master's, and that can be, again, in something more specific. So I did geotechnical engineering. There's also engineering geology degrees on offer. For example, at Leeds University, I did my master's at Birmingham. Also Newcastle, I think Plymouth offer various degrees. But then another key thing to do is try and get work experience within the engineering sector. You can do that now while you're at college, or when you're at university, or apprenticeship's different because you're already in the world of work. So thinking about those sorts of things now, it will either give you a taster of what and make you decide, yep, that is what I want to do, or it will make you realise that no, maybe I want to consider something different. So have a look into things like that. Now those are the sort of the steps. The opportunities at Atkins, we do offer apprenticeships, something that we probably started doing about 5 years ago, and it's rapidly increased. So we do offer post 16, which I'm not going to talk about because you're all sort of working towards your A levels now. But apprenticeships mean that you enter the world of work straight away post A level. You earn a competitive salary, you start real work from your first day. You'll be straight into projects, helping out, obviously, with a lot of support from mentors. and your eyes will be open to all the different areas of the business. And you'll work on various projects, and we will tailor your work to be able to give you experience in a whole host of industries as well. So we offer at Atkins a degree level 6, which is the equivalent of a bachelor's degree. So that's post 18, straight into the office. Generally, we've got an apprentice at the moment. I was talking to her earlier, and she's doing her degree at Derby. We also have a lot of our engineers doing it at Warwick. It's generally sort of a release day once a week, so you'll go to university 1 day a week and then in the office the other 4, over either 4 or 5 years. Her degree at Derby is 50% exams, 50% coursework, but you'll be obviously earning at the same time, learning on the job. I mean, I found from just doing a part-time master's whilst working that I learned a lot more from being able to work on the job while I was learning at university as well. But if you don't think that's for you, there's also, and you want to go to university and do your bachelor's degree, brilliant. We do also offer that a degree level 7, which is a master's equivalent apprenticeship. This is something fairly new. It's fairly new across the industry, but it means that you'll be working while doing your master's degree on an apprenticeship, which is different to what I did. But that is something that we do offer, and we work in partnership at the moment with the University of Birmingham as well on that. So that's something to consider, as well as potential option if you did want to go and do your bachelor's degree rather than start on apprenticeship post 18. The application process for that generally opens in autumn time. So this is similar for everything. You'll do your online application, and then there'll be an online immersion assessment, it's called. So scenarios that you need to think about, answer. That is sort of a key thing. That will be the initial decider whether you get called for interview or not. So make sure you put time into that. And then there'll be a virtual interview. So a lot of these used to be in person, but since the pandemic, we now do a lot of our things virtually. So you'll have your interview for that, and then you'll obviously get either offered the place, and you'll get the university agreement and the contract for that as well. Now, if apprenticeship isn't for you and you want to go off to university, we do also offer undergraduate placements. So again, that gives you that insight into the world's work throughout your degree. We have 2 types of placements. So there's a summer placement, which is generally 8 weeks. That's the placement I did. But we also do industrial placements. So some degrees, particularly civil engineering degrees, you'll have it'll be like a sandwich degree. So you'll do probably 2 years at university, a year in industry, and then do your final year. So we do also facilitate those as well. And from both types of placements, if you perform well, you may then be invited to become a graduate with us. You may be offered a graduate position or be invited to apply for a graduate position. Again, the application process is very similar. Once you've done your online application, you'll have the online assessment. For summer placements, that will pretty much be the decider. There may be an informal chat with the team that the HR would like to put you with. But all in all, it's the online assessment and your application that get considered. For industrial placements, you'll then go through the virtual interview process as well. Just because you're with us a bit longer, so we just need to make sure you're right for the job, and that you're also happy with the team that you're going to be joining for up to 12 months. We then post-degree, we've got our graduate programme at Atkins. Brilliant programme. That's what I joined, so that's what I've worked through. There's various career days. You'll have workshops throughout the 3 years on the programme, mentoring, buddies, various social activities. There's also an annual ski trip, which always goes down well with everyone. So it's not all about work, it's also about working together as a team and socialising and sharing your experiences with other graduates, because that everyone can support each other. Again, I'm not going to go through this too much, but yeah, very similar application process again. We don't generally take CVs, so when you do your online application, that all starts to try and tease out the information from you, so make sure anything you want is on there. And again, we go through that online assessment and then virtual interview. As part of Atkins and as part of our ground engineering and tunnelling team, we do also have a ground engineering academy. So you don't just get graduate scheme. This ground engineering academy is open to placement students, apprenticeships, and also the graduates. So it's a brilliant academy. You're generally with it for just sort of your early career, so the first 3 or 4 years. We have yearly field trips. These photos are from the field trip last year to the Isle of Wight, and it's just a brilliant opportunity to be able to get together with the other your early careers peers, and also more senior members of staff who are leading and sharing their knowledge and experience over a weekend. I know when I was with them, I've been to Scotland, did a trip to the Midlands. We ended up at Black Country Museum on the canal boat trips, but then also to the Lake District as well. And like I said, they've recently been to the Isle of Wight. So again, this is something a bit different. Not all companies offer this, but it's great for Atkins. It's something that definitely, I think, gives that a little bit more. You know, we do try and look after our early careers students from, as I say, summer student all the way through to graduates. So I realise I've probably gone through that quite quickly, but I just hope that gives you a little bit of an insight into what we do as geologists, engineering geologists and geotechnical engineers, a little bit of just about me and about what I've done from my time at King Ed's all the way through to where I am now, and then also just how you could become an engineer. There are various avenues. It's not all about going to university and getting a degree. We do have those apprenticeships as well, and obviously summer placements. So I hope that's given you a bit of an insight. Happy to take any questions. So yeah. Thank you very much, everyone.
Thank you, Kate. That's absolutely amazing. We've learned so much about your experience, but also I think seeing some of those sort of intense diagrams and things, I'm slightly overawed with that, but I'm sure our geology students and staff know all about it. I have got a few questions, but I'm glad that actually I can see that there are some questions being typed in, hopefully, and also Faye is putting some links in there as well. But a couple of questions first. Can you tell us how important it is to have design skills? You talked about using CAD/CAM. Is that something that you're trained to use, or something that students might be able to sort of have a pre-practice at doing?
It's something that you'll be taught about while you're with us. I mean, if you've got any skills, brilliant, but it's not a prerequisite. There's training on the job. Apprentices will learn with us. At university, you might pick up some skills, but we assume that people don't know how to use it. Like I say, it's not a prerequisite. There's plenty of training and learning on the job. So yeah,
that's great.
We can teach. Yeah.
Thank you. And perhaps I think Amrit has asked if you have any contact details. Would you be happy for us to share your details with students?
If you share my email address, that's absolutely fine.
That's lovely.
If they think of any questions afterwards, feel free to drop me an email and I'll get back to you with any.
That's super. We'll be circulating the recording to all students in the group, so we can do that with that. The other thing I was going to ask for somebody is, can you talk about perhaps other engineering roles or other roles that you work within a team, so that just students can see where your role fits in amongst the others? Yeah,
so in particular for what we do, within sort of ground engineering, there's a massive discipline interface with various other engineering disciplines. We work with the drainage team. Most of them are sort of civil engineers that have taken the drainage route, and also our structural engineers, because for us to be able to do anything, we need to know exactly what's going to be built, exactly for example, if they're going to build a building, how heavy is that building going to be? What do we need to know about how to keep that building up, basically, and stop it collapsing? So we work quite closely with sort of our drainage engineers, with structural engineers, also any highways team, rail team. So there's a whole host of different types of engineering out there, and a lot of different engineers that we will interact with as part of our sort of day-to-day job. And that is the one thing as well with Atkins, we all sit in the same office. We're in an open plan office. We integrate really well, and that's something I found while out on my construction experience. I was working very closely with a lot of different designers for different aspects, and it's something that a lot while I was out doing that role. So hopefully that sort of covers.
Yeah,
Yeah.
that's great. I think
Yeah.
Lewis has asked, are there any year 12 summer placements? Because one of the difficulties is I know that students are often competing with graduate placements as well.
Yeah.
And of course, it is very difficult to get actual in-person experience. What do you recommend for year 12s?
We do work experience. It's probably not sort of an 8-week thing. We might do a couple of weeks. If anybody's interested, say drop me an email, because I don't know that things like this are so widely publicised online. It's more of an internal in-office thing. We do for year 12, it is generally unpaid experience for a couple of weeks, but if anybody drops me an email, I can have a look into that and get some more details across, and see what we can do, see what we can offer, what anybody's sort of interested in doing. Because I do appreciate sort of when year 12 or whatever, it's very, very difficult to be able to get that experience, because like you say, it is competitive for university placements. But if anyone's interested, then drop me an email and I will pick up. Follow that up. That's not a problem.
That's really helpful, thank you. And Robin, who's one of our subject teachers, has asked, Robin, would you say the number of women in geotech is increasing in recent years?
Most definitely. When I started in 2016, there was very few women in the office. You'd probably say it was 10% women. I've found we are now I reckon we're probably sitting at 60-40 split in our team. Right. It's brilliant. I've got 3 summer students coming in that I'm mentoring this year, 2 of which are female. And so I think there's definitely an increase. There's a lot more support. I've been awarded the Women in Engineering for our team this year, so I'm sort of an advocate for that, for pushing women in STEM as well, and the numbers are definitely increasing. So that's definitely, I don't want that to put anybody off and to hold anybody back, because obviously it is a male-dominated industry, but it's definitely, the numbers are increasing.
That is really, really encouraging, and I know Robin's put well done there. And I thought from the kind of talk that you've given is the encouragement that you would probably give to students to sort of try something, open some doors, and you don't know what's kind of ahead, because I think from the experiences you talked about your travel abroad, your work in industry year, those are all things that you would possibly encourage students to take that leap of faith, almost to get engaged and see what happens.
Definitely. I mean, even I found I've tried, working on certain projects and things. I'm like, this just really isn't for me. And I've had that conversation with my line manager and tried something different. I think whether it's in the workplace or out of the workplace, take any opportunities you get. If it doesn't work out, then that's fine. I mean, a prime example for me, I was actually, before I started on my geology undergraduate, I was supposed to be doing geography. 2 weeks before I was due to start, I went, this is not for me, I don't want to do it, and that's why I took a year out, because I decided this isn't the right choice for me. I'm going to take that year out and I'm going to do something different, try something else. And also in the workplace, taking that leap of faith of moving away for 2.5 years down to Milton Keynes for that secondment. If it didn't work, there's always the support to come back, but for me it worked out really well. So try things, get the experiences, ask, if you are interested in doing some experience, there's a lot of local ground investigation contractors as well, who'd probably be more than happy with having people in for a couple of weeks or for a longer time to get involved, and just see, even if it's just for shadowing for a bit, to just see if it's something that you want to do. You don't know unless you give something a go, is how I take things. So
That's really helpful, and I'd encourage all students that work experience is evidently really important, whether you go down an apprenticeship route or an HE route, or whichever side of the STEM subjects you take, that hands-on experience of work shadowing, talking to people, networking, making contacts. And I'd encourage all students as well to set up a LinkedIn account. I've literally I didn't realise I hadn't linked with you, Kate, so I've just done that and posted as we've been kind of listening. And actually this is a critical part, I think, of our students becoming kind of familiar with the language of business, and particularly obviously obviously in the STEM subjects, making those connections. So I'd encourage all students to get involved.
Yeah, the other thing I would recommend as well is within the Midlands, we've got the Midlands Geotechnical Society, the MGS, and also the Midlands Geological Society as part of the BGS. So I would actively encourage you to join the students. It's free for students for both of those networks. I'll send you the details, Louise, then maybe if you could just circulate them.
Lovely, yes.
They do talks once a month. The GeolSoc do them via Zoom. So again, it's just easy to dial in. MGS do them at the University of Birmingham, but as always, potential just to start networking if it is an industry you're interested in, or even if you're not sure, it'll just give you an insight into what sort of things we do in industry. So definitely two key societies that I would definitely recommend students look into potentially joining as students.
That's really helpful, and I think engaging as a student and talking to people using the language that they're talking in business helps your application, whether that's for HE or an apprenticeship. So that's brilliant. We will include all of that information alongside the recording. I haven't got any further questions at the moment coming through, Kate. So if we can send any to you, and students, I'd encourage you to email either Kate directly or into careers at keds.ac.uk. Kate, it's been fantastic listening to you. We're delighted that you've been with us again. We always are. I can see I've got one more question kind of coming in, so I'm just going to wait. Zainab, I think he's just typing, so we'll just have a slurp of coffee. We'll just wait and see if that comes in, and then we will finish. But I'd like that question to come in if we can. If Zainab's quick enough to get that in. Okay. Yeah, I think we haven't got anything coming through. So what we'll do is we'll get those either directly to yourself or to Careers At. And Kate, thanks so much. And on behalf of our students and Robin and Faye and myself, thank you for coming along this evening. We look forward to seeing you probably at our in-person event, maybe in October, which is an employers event. So thank you again for coming.